All right, everybody. I'm Mike and César. We work at Twitter. We're going to talk to you about building the Android app at Twitter. So why are we here? What's the problem we're trying to solve? Can anyone like raise their hand and confidently say that they're happy with the speed of their build? Okay, there's a couple people. I recognize some of those people. Some Buck people maybe out there. But if you go on Twitter, which obviously we do, you see a lot of tweets like this that people are not quite so happy with how long it takes to build their app, and we weren't either. So we're going to kind of share our story of how we made some good progress. So I started at Twitter in October, and when I started, this is kind of like a description of what our build was like. We had two really large monolithic modules, one really large library, one really large app module, and then a bunch of modules that kind of had broken out over time. We're using the version 2.2 of the Gradle plugin. We're on a 3.1 of Gradle. I think that these were pretty much up to date at the time. But builds took and these are super optimistic. I did as much trying to find the best numbers I could. And it took 5 minutes to do a clean build, and almost 2 minutes to do, a minute and a half, 2 minutes to do just an incremental build. And that was the best case. You'd see plenty of builds that were 10 minutes or more, and just people were just really unhappy. And I like these numbers that Stefan gave yesterday. If we have 35 developers at Twitter, and if we do about 50 builds a day, and even for any 30 seconds we can saves 14 and a half hours per day of developer time sitting in front of their machine. And it's not just a time wasting thing. This also has the effect of people just see us in front of our laptops and say oh, you're just sitting around. We can give you more work to do, which is not really what you want. So faced with this, we went to the community to see what other people were doing, and a lot of people suggested for large apps to switch to Buck and use the OK Buck plugin. And we saw tweets like this that people were switching to Buck and that they were getting super fast builds, and that's all they had to do. And so we took the time to work on that using the OK Buck plugin, and we saw it really was pretty fast. Using the Gradle plugin that Uber came out with makes it very easy to set up. EXO package, which is this instant run type thing for swapping code, actually worked for us. These are the kind of numbers we saw. Clean builds were much faster, incremental builds were even faster. But that's not the end of the story. It's a lot less flexible because of the way the Gradle is allows you to customize a build. It's not officially supported by the tools team. We don't have a tools group at Twitter for building this, so we have to devote engineering effort to maintaining it. At the time, as of I think yesterday, they had Kotlin support to Buck, but that was not available. So if we wanted to use Kotlin, we wouldn't be able to. So for us, it seemed like the preferred way is to just stick with what is officially supported and work with what we have and to do what we can. So that's what we decided. We wanted to go down the path of making Gradle the way to go. So how do we do that? So there's a lot of easy stuff you can do. Some of it we had done, some of it we hadn't done. So really just follow the best practices. We're kind of going to go a little quickly through this, but there's tons of resources online and even here at the conference of what things to do. So at Google I/O, there was a talk by James, and he talked about a bunch of tips to make your build faster. And these are just a couple of the super easy ones that maybe aren't obvious, or maybe they are. Avoid legacy multi-decks, set your min SDK to 21. If you're using a recent version of Studio, it'll do that automatically, but if you're building from the command line, you want to make sure your builds have that. In development, disable multi-APK, just avoid doing more work than is necessary. Disable PNG crunching, kind of the same thing. In development, there's no point, just save some time. Avoid inadvertent changes. This one, I think a lot of people maybe don't have to do some investigating to find out what this means. There was an old version of or maybe even the current version of the Crashlytics plugin. It changes a resource file, and then that causes incremental compilation to not happen. So you might need to dig around to make sure that things aren't basically breaking incremental compile. Watching the amount of memory. So this is kind of not an exact science, but if you give too little, then you're going to spend a lot of time doing GC, and if you give too much, then like your GCs will be really long. And then make sure you enable the Gradle cache. That's a relatively recent thing. There's a bunch of other tips that were not mentioned that are kind of more Gradle related, but really good is to enable parallel builds. If you have a lot of modules, this can make a big difference. Using the configure on demand flag, or if you have like 300 subprojects or some large number, and each one takes like a non-trivial amount of time to configure, this adds up to being like a lot of time. So if you can tell Gradle just to configure the projects that they need to configure to complete the task that you want to run, you can save a lot of time there. And one that I had never seen before until very recently, but is pretty neat, but kind of dangerous, is the partial builds flag. So you can basically tell Gradle that you are smarter than Gradle and that none of the other projects have changed, and don't do any of the tasks in those projects. So if you say like assemble, it's on an app module, it's only going to run the assemble tasks needed from the app module. It'll basically ignore all of their library projects. So it's really fast, but can potentially like bite you if you actually do have changes in a library that you didn't know about. So the other thing that's kind of easy is just like make sure you keep up with Gradle, leverage the features that Gradle has. So here's kind of a timeline of the last few releases of Gradle. Some of these things like use like the daemon by default, faster dependency resolution, like those things you get for free, so you don't really have to do anything. Those are obviously the super easiest. Some of them you have to do a little bit of work for, but they make a big difference. So in 3.4 they added compile avoidance and incremental compilation. So in order to get this in Java libraries, it's pretty easy. Just change your apply plugin Java to apply plugin Java library, and then use the API and implementation configurations instead of just marking everything as compile. And then, so pretty much like this, switch over your test compiled, like test implementation compiled, the API or implementation as needed. And then in Java projects, you might want to declare the annotation processors in the processor class path. So you can do something like this. You specify the annotation processor configuration, and then you can declare your dependencies like this. It's not necessary in Android projects because Android already has the annotation processor configuration. And then also another thing that is not enabled by default is you will want to enable incremental compilation in Java projects that by default right now is not enabled. So going back, like I said, some of these you get for free. Build cache, that's a big one in 4.0. It's really easy to enable. You just set this in your Gradle properties and cacheable things are cached. Pretty easy. And then what we do in CI, we have many workers running on the same machine, so we move the build cache to like outside the execution so that multiple jobs can share the same cache locally, and then there's a remote cache. So you should do all that stuff, but besides that, there's like a lot more you can do, and you probably will need to do. But in order to do that, you kind of need to learn like how to figure these things out. So learning the tools that Gradle provides is basically the most important thing. I like this quote. It was not a tweet from Abraham Lincoln, but basically what I take it as, learn the tools and it'll save you a lot of time later. So the first one that I think hopefully people know about is -- profile. I recommend just putting some of the stuff in like an alias so that you always run with -- profile, so that later when your build is slow, you can just kind of go back in your build directory and you can just kind of browse through them. So -- profile generates a report in the build directory, gives you information about the configuration and task execution, indicates if a task was skipped or if it did no work. It looks kind of like this. You can kind of click through to see like individual phases. So here's just looking at task execution. If you're wondering like why all I want to do is build an APK, like why is this taking so long? You can see that lint is taking up 40 seconds. Maybe you didn't even need to run lint, so maybe you can exclude it from as part of this. You can also see that by default, like running assemble, you're going to compile like release and debug. That's not really necessary if you just want in development. So, like things like this are like become super obvious. And the next thing, another tool that's useful is Gradle Enterprise. If you work at a company as Gradle Enterprise, if you're working on like a public project, you can use Gradle build scans, which is like a publicly available version. Super easy to use. You just apply a plugin, you add this closure to your build script, and then when you run your builds, you just use --scan, and you get, after your build is over, you get a link, and it takes you to either, this is the Gradle Enterprise dashboard with like all of your builds. When you can click on one, you can kind of dive into a lot of information that you see. Like maybe the most important one, if you're trying to speed up your build, is kind of looking at the timeline here, and it's sorted by like the slowest tasks first. So in this case, you could say, oh, like launcher test is taking a really long time, and you can dive in. Gives you a little bit more information, again, sorted by the longest by default. This was useful for us because it also tells you the type of task, the class. So when things that maybe in the Gradle plugin were taking too long, we can immediately like see what class it is, and then we can look at the Gradle plugin source and kind of track down, like, is it our fault? Is it a bug in the Gradle plugin, and report it, things like that. Gradle Enterprise has like a bunch of other really useful bits of information on the dashboard. Like it kind of will show you all your test execution information, how long each test was running. Like this test takes 10 seconds, like maybe that's not correct. And then the part that I really like is it gives you all this build property information, so that when people kind of in our org complain and say, hey, my builds are taking a really long time, I can kind of look at it and say, oh, well, you're not using like the build cache, and you're not using some of these other flags. And you can see like some other information about like the VM, how much memory they're using, so I can give them some information and like some hints on like what they can maybe change on their machine or like on their local config to help explain what's going on. The next one that was really big for us was the Gradle Profiler. It's this project on GitHub that you can check out. It's pretty easy to use. You just run this Gradle Profiler, you pass it the project that you want to run a profile against in these scenario files, and then and you pass it like what type of profile you want. So in this case, I think the default, it might be Chrome Trace. So you said Chrome Trace profile, you pass the scenario file, and you tell it what kind of scenario. And what those look like is kind of like this. You create a scenarios file, and you tell it what kind of tasks you want to run. So we want to assemble like our debug APK, and then there's different types of changes that you can make. So it can be a clean build or an incremental build. So in this case, we're going to do a non-ABI change. So it's going to change just the maybe not the method signature, but maybe change the method body. So we can see like what kind of incremental compile times you get. And then you can also specify how many warm-ups you want the build to do, so that you're not starting from a clean build, which is not really necessarily like maybe what a real-world situation is like. And so after you run this, you'll get a Chrome trace. So if you've used systrace before, you might be familiar with what these look like. You can zoom in and pan around and see get detailed information on each of these things. But it's also immediately useful to kind of see at the top, this is the CPU usage, memory usage, and like you can also immediately tell that there's not a lot of parallelism going on like towards the end of the build. The beginning is great, like we're maximizing our CPU usage, but towards the end we have these really long monolithic tasks that are taking a long time. And then another tool that we've been using is called YourKit. It's not like a Gradle tool or like something from Google. It's like a third-party thing you have to buy. But I saw this tweet, and it basically says, change my life. And if you use the tool, you can kind of see why. There was another tweet that said that every time they open it, they have to hate themselves, but they feel better for it later because you're diving really deep into some of these issues. So this is what the tool looks like. It has all these tabs. I've not nearly used all of the features, but so the stuff that I have used has been very useful. So you can immediately see profile what your CPU is doing. So you can see how long particular methods and maybe an annotation processor are taking. You can get snapshots of what individual threads are doing. So you can look into the call stack and see where maybe there might be bottlenecks. It's really easy to set up. You just in your Gradle properties, you pass this really long string of random parameters, and you turn the daemon off so that it will start up the YourKit process and hook it up. And then what we did is on exit, we'll dump memory profile so that when the process is over, you can kind of see what kind of stuff is there. The docs for this are online, so you don't have to remember all that weird stuff. And then the other thing that's really cool is that the Gradle profiler will actually spit out a YourKit profile so that you can then look at what the heap would look like and see if you're looking into memory leaks. It's a much better tool for investigating. So, and then the last thing that is really useful is just kind of pretty obvious, but sometimes really hard to trudge through, is just use the logs. If you've ever run Gradle assemble -- info, or even with debug, you have just millions of lines of stuff. But there's a lot of good things in there that sometimes will help you debug. When you see tasks are not running the way you expect them to. You can see the compiler arguments, the class path. So if things seem to be doing the wrong thing, you can kind of dive in, and it actually will show you the compile command that was used and stuff like that. So you can kind of see okay, here's a processor path, the class path, view what's on there. So basically, there's just a lot of different tools that you need to go to that maybe it's not just as simple as update Gradle and then it should be fast, or update the Gradle plugin and then it should be fast. There's going to be a good amount of investigation that you need to do, and those are just some of the tools we've used. And then now César is going to talk about how we use those tools in some specific situations and found particular bugs and things you can, concrete things you can do with them. So, go ahead.
So you've seen some of the tools that we've been using. Now what I'm going to talk about is how we have used them effectively to figure out build issues and to optimize performance. And when I say effectively, I mean in a hacky way sometimes. So you gotta do what you gotta do to make things work. So first, upgrading to the Gradle plugin to 3.0. We usually do not upgrade to the Gradle plugin alpha version of the Gradle plugin So we usually don't upgrade the plugin until it's stable. But this particular version was so much better than the previous versions. It's so much faster that we just couldn't wait. We have compiler avoidance. We have variant-aware dependency management, as you know, all of the good stuff that Zav talked about yesterday. Now, it's still kind of finicky, and a few things do not quite work. So we enabled it based on a flag, so that we could switch it on and off based on a task-by-task basis. So we are running it in CI for some tasks that we know are working. So we just set the flag based on this command line parameter, and then we select the version of the plugin that we can use that we use based on that flag. Now, of course, it's not that easy since there are incompatibilities between 2.3 and 3.0, and there are a few more things that you have to do. So you have to define your flavor dimensions, for example, which is as easy as doing this. It's based on the flag. You have to disable AAP2 and new resource processing. Well, if you're using Roboelectric, you will find that new resource processing will make some of your tests fail, and it just plain does not support AAP2. So 3.5 version of Roboelectric will support it, but for now, we are just disabling it like this in Gradle properties. And then finally, if you want to be able to run both 2.3 and 3.0, you need to enable API and implementation configurations in 2.3 since those do not exist, right? So we just fake them. It's as ugly as this. So if we are running in 2.3, we just create configurations like this. Now, compile will extend from API and implementation, meaning that when 2.3 looks at the compile, I know, exactly. I said that it's going to get worse, so I'm warning you. When the plugin looks for dependencies in compile, it will get everything from API configuration, and it just works. There are a couple of other things that do not quite work in Alpha 4. There is a crash when running test. There is a memory leak in merge resources. I believe that that's fixed in Alpha 5, and that will be out soon, right? So I'm not bothering to mention those. Lint is also it has some trouble, some problems. So we are not using 3.0 for Lint just yet. But for the rest of it, running tests and building APKs and validating changes in CI, everything is running on 3.0 already. And I think it may be like twice as fast than it was. So that's quite impressive. So moving on, up-to-date check issues. You may have noticed that sometimes you run a build, then you run the build again, you change nothing, and still you're getting some tasks are running. And those issues are pretty hard to figure out. So here is something that you can do. You can look at the logs. This is the debug log, and there is a lot of information there as to why was a task running. So you can see that for each task that runs, you get some output that tells you whether it's up to date or whether it's running because a particular property changed. So here you can see why this particular task is running. Here you can see that this task does not need to run. And here you can see another one case where Ming SDK changed, so you need to rerun. We sort of hacked Gradle in order to get these logs automatically saved into a file in every one of our builds, because usually by the time you realize that a task is running that you were not expecting to see, it's too late. You cannot go back and enable the debug log. Fortunately, this is no longer needed since Gradle Enterprise 17.4 that came out just a couple of days ago includes all of this information in the output, which is nice. You can now click on the link that you get at the end of the build if you're using Gradle Enterprise, and you can go see what happened. So let me give you a few examples of the sort of issues that we've seen. There's understood invalidating caches. We had a lot of discussion about that one. As it turns out, Android Studio will inject in Gradle builds its own local Maven repository, and that's meant so that a build of Gradle, after Android Studio has been installed, will be able to find all of these local artifacts without the need for re-downloading them. So it improves the experience of the new user, but injecting a new repository is affecting the class paths. The result of this is that you run your build or your sync in Android Studio. It will build everything. Then you go to Gradle. Gradle finds that the class path has changed for pretty much everything. So it will rebuild everything. And now if you go back to Android Studio and you rebuild again, you will see that you have to build everything again. This, it's for those of us that are building in the command line is causing a permanent problem. And this has actually been a problem for quite a while. So now I'm thinking that the feeling that we've been getting that the sync was just crazy slow, may have been coming partially from saying that we were rebuilding everything even though we had just built it. So we just added this at the top of our scripts, just remove all of the repositories since we know that we don't need them, and that fixes the problem. Another typical one is with annotation processors that don't generate consistent code, which may not be obvious, but if your annotation processor is reading multiple classes and it's generating code, let's say one list of some code that lists all of those classes, the generated code may depend on the order in which the classes were processed, right? So ordering them is important to make sure that your annotation processor are not causing rebuilds. Missing dependencies among tasks. This usually will fail the build. I'm bringing this up because there was this particular bug in 2.3 with a missing dependency between two tasks that would cause rebuilds. So we found it in a similar way, and we patched it just with this. It's no longer an issue in 3. I see that Zav is raising an eyebrow. Like I said, you do what you have to do. So this is no longer an issue in 3.0, so you can forget. But it's a good example of some of the issues that you may find. A Ming SDK is an interesting one because you know that the typical guidance for building, for saving the legacy multi-text is that you set your Ming SDK to 21 in debug builds. Now lint will need 17 in order to detect uses of invalid APIs. So if you were to switch between running lint and building APKs, you will see rebuilds as well, because the Ming SDK is changing. So this is no good fix for this. So I'm hoping that the Google team will potentially add a lint option to override the Ming SDK that lint uses, or something like that. So debugging Gradle, when nothing else works, you just need to go and figure things out. If anything, if you have to report an issue, you probably want to have the detail in order to be able to explain exactly what's happening, right? Otherwise, it's unlikely to get any attention. So debugging Gradle is not particularly hard. You clone Gradle, you run Gradle IDEA in order to get an IntelliJ project, and you're done. You're off to go. So you can then start your Gradle build with disabling the daemon and then passing that parameter so that it will wait for the debugger, and then you can just use the typical remote configuration to attach into it. Set breakpoints and you're off to go. I usually have IntelliJ open at all times with Gradle just because it's nice for browsing the documentation, but it's useful that I would want to debug the AGP. And with the AGP, many times we just don't have the source code, right? The repo is updated once the builds become stable. So for that, I just add the library. You can just add the jar file, and IntelliJ will be able to use it, right? So you go for Maven, you select for Maven, and it just doesn't work. Or I could not figure out what kind of sorcery you need to use in order to configure IntelliJ to fetch resources from the Google Maven repo. So, well, we can get it to work anyway in a circuitous way, where you can just find the jar files that are locally in your cache. So they're under files 2.1. You can find them easily, and then you can go back to IntelliJ. You can load the jar files or directories, and there you go. Now, once they're here, you can find the classes directly. In principle, you would be able to set breakpoints, except that you don't have the source code, of course, because we are not using Maven. So in order to get the source code, you can just download it, and this is, like I said, not awesome. So you can go find them directly from the Google Maven repo, and you can attach them in Android Studio. And now you can open any one of the classes. You can open Task Manager, which is where all of the tasks are being loaded. You can open the task and see how they are configured. So you can do this with lint as well, and I do it all the time. Anytime we find a lint issue that we are not expecting, it's the only way I find figure out what's exactly going on. So yeah, if you find any bugs, ideally you want to fix them or to try them out, right? So the next thing would be to patch AGP. Now, yeah. So patching AGP is not. I mean, you would want to obtain the source code and I don't know, somehow make it work. There is no way to do that properly if you don't have access to the source code. So I'm warning you, hacks ahead. There is this one thing in Gradle, that's the build source. And one nice thing about the build source project is that it gets compiled automatically up front, and it gets added to the class path before any other dependencies. Now, you may know that class paths are scanned linearly, right? And the first class that you find is the one that gets loaded. So you can just add your classes, you can patch them, and it just works. So I just added that. You can do anything that you want. So hopefully you can then file a patch, file an issue, so that gets reported. I'm hoping, I'm expecting that filing an issue along with a fix or a suggestion of a fix may make things easier for people at Google. So moving on, it's not so hacky from here, I think. Addressing memory issues. We mentioned earlier that you may have trouble with your heap being too small, with your heap being too large, and you may wonder how to figure those out and how, and in particular how to find leaks. So this is actually you can see here a trace of a build that's completely starved for memory. This is 3.0. I mentioned earlier that 3.0 had a huge leak. So you can see how the heap up there is completely maxed out, and the garbage collection is happening all the time. So it's no wonder that the compilation is taking like a couple of minutes or even longer. You can see similar information now in a build scan. There is total garbage collection time, and there is memory usage. And in order to address this, you could, well, go the easy way. Maybe increase the heap size, or you can try forking the compilation to a separate process, so it gets a separate worker, so that you will avoid all of the garbage collection in the daemon. Or you can try to figure out the leak, and for that we can use YourKit, right? So you see that YourKit here is configured for doing sampling and then dumping the heap at the end of the execution. So here's an example, and this is an example of Gradle 3.0. So you look at the output, and you can go to object dominators. When you're suspecting a leak, this is your best option, because the object dominator, a dominator is an object that's solely responsible for holding a huge amount of memory. So you can see here that merge resources it's holding on to 1.5 GB out of memory. So looking closer into these objects, you can see this particular field that's holding on to the resources after they have been processed. So obviously you can discard them at this point. So well, we just did that. So this is why we have been able to use 3.0. It is fixed in alpha 5. So like I said, do what you have to do, and then report an issue so that they can fix it. And finally, fixing low parallelism, which you saw earlier, right? You have a build like this. You can see the total build time. You can see the task execution time and the overhead. So in this particular case, we had 8 workers, and we got a speed up of 2x, which is nothing, right? You can see that in a build scan as well. You can see that here. So that's pretty awful. Now you get to this point, all you can do is modularize, where there is nothing that the tools can do for you if your build is not meant for parallelism. So what advantage can you get out of that? Because it takes a lot of effort, right, to take a large legacy application and break it down into smaller modules. You would improve compiler avoidance using the API and implementation configuration. So using an implementation configuration anytime you can would make it just improve the avoidance compilation. Optimizing the caching of build artifacts. More numerous number of smaller build artifacts are more easily cached. More efficient parallelization, which is what we're looking for. Better code architecture, which is generally a good thing if you can isolate behavior in well-defined layers. And final job granularity in CI, since as your build gets larger and larger, being able to distribute smaller tasks to a larger number of workers will give you better performance. So as your build gets bigger, and you add more and more modules, configuring Gradle properly for the larger amount of modules will make a difference. So Here's some ideas for things that have worked for us. Using shared Gradle configuration files is very convenient, so that you don't have to update every single project every time that you want to change. So these are the files that we're using. We have common properties. We have a checkstyle.gradle. You can see this is a typical checkstyle configuration that we apply to all of our projects. Link.gradle, similarly, Java library.config. So you can see here, for example, that we have Java library at the top. We mentioned earlier, in order to switch from 2.3 to 3.0, no, sorry, this was 4.0 in Gradle. That in order to upgrade to 4.0, you have to switch your plugin from Java to Java library. So we do it in this one single place. And down here, you see the annotation processor configuration that's meant to be available in every Java project. We just added it to this file. We have Android common config. We have the Java annotation processor config and the Android common config, an Android library config. Similarly, so you see that this is just applying the library plugin and bringing a bunch of other configurations, and an application config. Now, having this, our project configuration is as simple as this, where we have one first line that says declares that this is an Android library, and then whatever dependencies that are relevant for this project. Second thing is making sense of build errors. You have lots of modules that are spitting out errors in lint, checkstyle, unit test. So having some system that will collect those errors and show them, I don't know if you can see that well, but show them to you in a way that's easy to consume. That's super convenient. So here's an example of a unit test that failed, and you can see the description, you can see the command that you can use in order to run this test. You can see a report that you can command click into to go directly into the call stack. And then finally, these are just a bunch of tools. This is just a few ideas on things that you may want to consider for yourself. This is some tools that we use to select the projects that you want to run tasks on. So we have like 100 projects, and we only made changes to 2 or 3 of them. We may want to run tests only on those, right? So we have these tools that do exactly that: lint, whatever has changed, or checkstyle, or test. And then some closing advice. You should use API dependencies sparingly for improving compiler avoidance and reduce class path sizes and hide implementation. Isolate annotation processing. As you probably heard, annotation processing will disable incremental compilation. So for now, until that's fixed, isolating annotation processing to smaller modules, like let's say a module that contains your dagger graph or a module that contains your JSON definitions, would avoid that problem or minimize the impact. Remove bottlenecks in your graph. If you have this God module, everything depends on you're throttling your build, right? Because as you get to that point, you will get everything you will block on that compilation. So it's just watching for those modules and breaking them down will make a difference. Using Java modules when possible for hygiene and just because they're faster and more reusable. And then use the new refactors in Android Studio to move resources, since, well, it's a lot of work and every little help is useful. And cool. Mike will do the wrap up.
All right. So just to kind of bring everything back together, and then everyone can go to lunch, because that's what time it is. Just to recap, this was our build in October. So last I checked, now we have 93 modules. We still have these 2 fairly large modules, but they're considerably smaller now. We are using the latest Gradle plugin. We also are, obviously, like César said, testing the new one, and we're using Gradle 4.0. These are the numbers that we had earlier in the slides, kind of what builds took. And as you may have seen in the keynote yesterday, we are actually seeing like pretty comparable numbers in 3.0 that we saw with Buck. And just kind of the closing advice, like it's really just like a matter of profiling the hell out of everything so that you can find all these places where tasks are not being kept up to date when they should be, finding why those things are not doing what you expect them to, And then lastly, like in order to just get the most parallelism, is just break down the large modules into smaller ones. So I know it sounds easy, but it's actually a lot of work. But that's how you get like really fast builds. So that's it. That's all we got. We can take questions, or I think we're like right out of time. We can always you can find us out there after. So that's all.